Fourier transform can be obtained from Fourier series. The Fourier series, the Fourier series can be expressed as f of x. F of x is a0 plus, this is summation n. N is say minus infinity to plus infinity, a n cos n pi by cx plus b n sine n pi by cx. This one is the Fourier. And the coefficients an, a0, an, bn, where a0, an and bn are the coefficients in Fourier series. So substituting the values of coefficients, we have what we have. This is fx, and the value of this is 2c integral. If we can find from minus c to plus c, this is minus c to plus c, then f of t dt plus this summation, and an is 1 by c minus c to plus c, f of t, and an is cos n pi by c into t into this value is an, and then cos of n pi x cx plus bn. Again bn is 1 by c minus c to plus c, f of t sine n pi by ct. This is your bn into sine n pi cx. This one. Now, after substituting these values, this can be simplified as 1 by 2c minus c to plus c f of t dt plus. Here 1 by c integration of this minus c to plus c, we can take common 1 by c minus c to plus c of f of t, and then inside the bracket there is cos n pi by c t into cos n pi cx plus sine n pi c of t sine n pi cx. This one. So this is simple trigonometrical expression, cos A cos B plus sine A sine B. So it is cos A minus B. So this factor is nothing but cos n pi c t minus x. Here it is dt. This is dt. Inside the bracket you can say. So dt, and here it is f of t integral minus sign to plus sign 1 by c, this whole integration summation of this, and this is equal to 1 by 2c minus c2 plus c f of t dt. Now again, there is a common terms of integral and 1 by c. So we can see 1 by 2c minus integral to plus c f of t. F of t, you are taking this dt common. So this part is, the whole part is taken out. So it is 1 plus 1 by c. So this is summation 2, and then cos n pi c t c t minus x. This is t minus x, this part, and dt is taken out, so no need to write again dt. This part here, it is closed. This is closed. Now this factor is important for us. This factor is important. So this is fx, this is fx. Now consider one plus summation 2 cos n c t minus x. In this case, this can be expressed as summation minus infinity to plus infinity, the value of n, and this is cos n pi by c t minus x. So what is the meaning? If you are expanding this one, if you are expanding this c, here it is plus infinity, and you are expanding here, it is minus infinity. So you are taking from minus infinity to plus infinity. So the whole expression is included in this case. The whole expression is included in this case. So we can write this value. We can write this value in above equation. So we have, let us see the next page. Let us save it and go for next full. So this fx is 1 by 2c minus c2 plus c f of t dt into this n is equal to minus infinity to plus infinity cos n pi by c t minus x. We have this expression. Now again, if we take this one as 1 upon 2 pi, so what will happen? 1 upon 2 pi of this minus c to c f of dt, and here it is c. So this pi by c summation cos this n this n pi c t minus x. Let us assume that n pi c is equal to u. N pi c is equal to u. Then pi by c is equal to u by n. Pi by c is equal to u by n. Means u is divided in n part, and then each part is very, very small, and suppose this is small value du. So what we'll get? We will get this one is pi by c is du, and summation, this summation is minus infinity to plus infinity, minus infinity to plus infinity summation, and n pi by c, n pi by c is nothing but u. So these are three symbols, and these symbols can be written in terms of integration from from the definition from the definition of integration from the definition of integration we have, this is pi by c minus infinity to plus infinity cos n pi by c t minus x can be written as this minus infinity to plus infinity, and here it is cos u t minus x into du, and t minus u into du, by substituting the above assumptions. And if this definition, from the definition, this is defined, and this is defined part, summation of very small parts. So substituting this integration in above, so from top equation, we have what we have, f of x is equal to 1 upon 2 pi minus c to plus c f of t dt, and here minus infinity to plus infinity cos u t minus x into d, t minus x into d, or we can say 1 upon 2 pi minus infinity to plus infinity ft, here it is minus infinity to plus infinity cos of u t minus x du dt, or 1 upon 2 pi minus infinity to plus infinity, here it is minus infinity to plus infinity f of t cos u t minus x du dt. This is f of x. This is f of x. Now in this f of x, we can have the similar terms in the expansion, that is 1 by 2 pi minus infinity to plus infinity f of t, and this cos can be expanded at cos ut into cos ux plus sin ut into sin ux dt du. So with this 1 by 2 pi minus infinity to plus infinity, this minus infinity to plus infinity f of t cos ut cos ux, the first part, and then dt du plus 1 by 2 this f of t sin ut sin ux dt du. So what we find, there are two terms. One is cosine terms, other is sine terms, and these are known as uh, sine integral and cosine integral. These are known as sine integral and cosine integral. So we can have this one in the part, that is, we can come here, case 1 when f of t is odd function, f of t is odd function, then what you find, odd multiply with even function is odd function, and when it is odd function, then a0 is 0, an is 0, bn is not equal to 0. So this f of x is equal to 1 by 2 pi. This is minus infinity to plus infinity. This is minus infinity to plus infinity, f of t sine ut into sine ux du dt. That is, this is sine integral. It is sine integral. This is sine integral. So sometimes the question is, find out the sine integral. Case 2, when f of t is even function. F of t is even function. So what even into even is equal to even. So this is a0, bn0, and an is not equal to 0. So this f of x is 1 by 2 pi. These are the two integrals, and f of t cos ut cos ux du dt, and this is known as cosine integral. This is known as cosine integral. So in this way, we can categorize two cases, sine integral and cosine integrals, as case 1 and 2. Now consider the function f of x is odd function, then minus integral to plus integral f x dx is equal to 0. This implies that minus integral to plus integral sine ut minus x du is equal to 0, because this is equal to 0. So this function is 0. So what we find, we will consider I upon 2 pi. This is minus f of t sine ut minus x minus x du dt is equal to 0. This is 0. So this sign of this function is 0. And if we add in cosine function, then what will? By adding this 0 value expression in the above cosine expression, that is f of x 1 upon 2 pi, this f of t cos ut minus x du dt plus I upon 2 pi, this f of t sine u t minus x du dt. So what is the advantage? We take the common of this various function, then here cos u t minus x and sine u t minus x along with I. So these two terms combine to form an exponential terms. This can be visualized as this f of x is 1 by 2 pi, these two integral f of t, then cos u t minus x plus I sine u t minus x du dt. That is 1 by 2 pi f of t, and this function, this is nothing but e I u t minus x du dt. This of f of x. This is f of x. So what we find, this is the Fourier transform e raised to the power I u t minus x is equal to cos u t minus x plus I sine u t minus x expression. This is the complex expression, so it is called as Fourier complex integration. This is known as Fourier complex integration. Fourier complex integration. Now this Fourier complex integration, f of x can be written as 1 by 2 pi integral e raised to the power minus I u x du into integration f of t e I u t dt or 1 upon under root 2 pi if it is taken here minus I u x du, then 1 by under root 2 pi, this is f of t e raised to the power I u t dt. So this bracket term can be expressed as f of x. So this f of x is equal to 1 by under root 2 pi e raised to the power minus I u x du into fu. This is fu, where f of u is equal to 1 by under root 2 pi integral minus infinity to plus infinity f of t. This is f of t e raised to the power minus e raised to plus I u t dt. So this one is f of u. So the above part, that is here, the above expression can be written as f of x is 1 upon under root 2 pi, this minus infinity to plus infinity, f of u e raised to the power minus I ux du and it is known as Fourier transform. Known as the Fourier transform. Fourier transform. And this can also be expressed as this can also be expressed as also be expressed as uh, f of x is equal to 1 upon under root 2 pi minus infinity to plus infinity f of s e raised to the power I s x ds, where s is the uh, terms and this is known as inverse Fourier transform. IFT, that was FT, Fourier transform is FT, and inverse Fourier transform is IFT. You can write this one is IFT. Some useful results. Some useful results are used 0 to infinity sine ax by x dx is equal to pi by 2, 0 to a e minus x squared dx is equal to under root pi by 2 and minus infinity to plus infinity sine mx upon b square plus a square dx is equal to pi by a e raised to the power minus a n sine bm when m is greater than 0. So these are the important useful integrations that are used during the solving the equation. Now take the example. That write the function as a Fourier integral and evaluate it, what is 0 to infinity sine lambda cos lambda x upon lambda d lambda. of given function, what the function is, 0 for mod x is greater than 1 and 1 for mod x is less than equal to 1. So find out the Fourier transform. What do you mean by this conditions? That conditions is something like this: x, x. So this value is minus 1. Here it is plus 1. So mod x is greater than 1 means from this side and this side, left, right. The value is 0 and mod x is less than equal to 1. The value is 1. This kind of function. So for this kind of function, we have to find out the Fourier transform. Fourier transform of the function. What will be the value? What will be the value? So you have to put this value of x and then find out the integration. The integration given terms is here, and then you have to do all this phenomena by substituting the value. So this is about the today lecture, and this example is for assignment that you have to do this example and other examples, and then we will like to discuss the next lecture. So after this, if you have any problem